Imagine trying to pin down a particle so perfectly that you know exactly where it is and when it will be there. Now imagine hitting an invisible wall, a fundamental law of the universe that says this simple task is impossible. Today, we are breaking down the latest discovery that reveals a hidden quantum limit preventing electrons from ever having perfect position and timing. This isn't just theoretical physics. It's changing how we build the next generation of computers, solve energy crises, and understand the fabric of spacetime itself. By the end of this video, you will see why this new invention is the most critical breakthrough in quantum history and exactly what it means for our future technology. For decades, we've been told by textbooks that Heisenberg's uncertainty principle was just a fuzzy limit on our measurement tools. We thought if we built better microscopes or faster clocks, we could finally nail down the exact position and momentum of an electron simultaneously. But recent findings have shattered this comforting illusion. Scientists have uncovered a hidden quantum limit that acts as a hard ceiling, preventing an electron's position and timing from ever being known with perfect precision, regardless of how advanced our instruments become. This isn't about noise or error. It is a fundamental property of reality itself. Think of it like trying to photograph a speeding car in slow motion while simultaneously measuring its exact weight down to the milligram. In classical physics, you might struggle, but you could theoretically get close enough. In the quantum realm, the particle doesn't just resist being measured. It refuses to exist in that state entirely. The new research suggests there is a specific mathematical boundary where the uncertainty becomes absolute. If an electron attempts to settle into a definite location and time slot, the laws of quantum physics immediately push back with a force stronger than any classical repulsion we've ever modeled. This discovery redefines what it means for matter to exist, suggesting that the act of defining where and when are mutually exclusive in ways we never imagined possible until this moment. This revelation goes far beyond just particle physics. It is fundamentally rewriting our understanding of gravity and its deep connection to space and time. For years, the leading theory has been that quantum mechanics and general relativity are two separate languages speaking different dialects about the same universe, one dealing with tiny particles and the other with the vast curvature of spacetime. But if we cannot even pin down a single electron's position and timing perfectly, then our models for how gravity interacts with those particles become suspect. Quantum science may now reveal that everything in the universe is connected through higher dimensions that our current perceptions simply cannot access. The hidden limit on particle precision might be the key to unlocking the secret of why spacetime has the structure it does. Imagine a vast, multi-layered network where the inability to perfectly define local coordinates forces particles to communicate across these higher dimensions. This could explain phenomena that have baffled physicists for centuries, from black hole radiation to the nature of dark matter. The new invention effectively bridges the gap between the quantum world and the cosmos by showing us that the very limits we observe are actually guides to a deeper, unified structure. It suggests that spacetime itself might be an emergent property arising from these quantum constraints rather than a pre-existing stage upon which physics plays out. While the theoretical implications for gravity are staggering, the practical impact of this discovery is already revolutionizing how we manage energy in our devices. This new invention specifically targets and optimizes quantum-limited heat conduction, allowing for incredibly efficient transport of thermal energy from point A to point B with minimal loss. In traditional electronics, heat is the enemy, causing slow processing speeds and eventual hardware failure. But in the realm of quantum computing, where transistors operate at near absolute zero temperatures, managing that residual heat becomes a matter of life or death for the machine. This breakthrough means we can now channel heat through materials in ways previously thought impossible by standard thermodynamic laws. Imagine a processor that runs millions of calculations without ever overheating, because the quantum limit is being harnessed to create a superhighway for thermal energy. Developers are already seeing this translate into faster, more stable quantum computers that can maintain coherence longer than previous models allowed. The ability to move heat so efficiently means we don't need massive cooling systems or complex insulation. The physics of the material itself does the work. This is game-changing technology that could accelerate the transition from experimental prototypes to real-world applications in just a few years, making quantum computing accessible and reliable for industries ranging from pharmaceuticals to financial modeling. So what does this actually mean for you in your daily life? The implications extend far beyond the lab bench into the very fabric of how we build the future. As quantum computers become more powerful, they will unlock solutions to problems that are currently unsolvable, from designing new drugs to optimizing global energy grids. The fact that we now understand these hard limits gives us a roadmap for engineering systems that respect nature's rules rather than fighting them. We are moving into an era where technology doesn't just adapt to physics, but works in harmony with it. Furthermore, this discovery opens the door to entirely new forms of communication and sensing. If position and timing cannot be perfectly known, then perhaps we can design sensors that are even more sensitive by exploiting those inherent uncertainties. Think of medical imaging or navigation systems that operate on principles currently considered theoretical sci-fi. The practical takeaway is clear. The next decade will see a boom in devices that leverage quantum uncertainty as a feature rather than a bug. Whether you are interested in the latest tech gadgets, the future of artificial intelligence, or simply how the universe works at its most basic level, this discovery marks a pivotal turning point. We are no longer just observing the quantum world, we are learning to conduct it. We have traveled from the abstract limits of particle precision to the grand architecture of spacetime and back down to the practical engines that will power our future. The key takeaway is simple yet profound. The universe has rules, and they are more rigid than we ever imagined, but those rules also hold the keys to unprecedented innovation. By understanding these hidden quantum limits, we gain the ability to build faster computers, solve complex problems, and deepen our comprehension of reality itself. If you found this deep dive into one of science's most exciting frontiers as fascinating as I did, make sure to hit that subscribe button so you never miss an update on how physics is changing our world. Drop a comment below telling me which part surprised you the most, the gravity connection or the heat conduction breakthrough. Let's keep the conversation going about what comes next in this quantum revolution.